Alright, this is the lesson on nets. First of all, we have to define a net. A net is a 3D object. If you'd like to pause the video at this point in time to write that in, you're welcome to. And then the other part is we have to figure out what is the purpose of a net. Well, the purpose of a net is to be able to unfold a 3D object to find the dimensions in order to calculate the surface area. So the reason why we look for nets or we draw nets is to be able to find the surface area. Alright, so let's have a look at our object. I'm just going to move that up so we have lots of room. First thing we need to do is check to see that all of our dimensions are written in. If we're going to draw a picture, we need to make sure that we have all the dimensions. So if we look at this line here, that's 6 centimeters. That correlates with this one over here, so perfect. Those two have dimensions. Now if we look at this one here, that's 10 centimeters. We know that this measures the same as this, and that measures the same as this one. Perfect. And then we're going to look at this, which is 26 centimeters. This is 26 centimeters. And this is 26 centimeters. You don't have to draw these lines on here. I'm just drawing them on so you can see which dimensions correlate with which sides. So as you can see, there is this side we don't know, which is this side and this side. So we have to do a little bit of figuring here. So how we figure this out is, I'm just going to color in this little triangle so you can see that there's a little triangle here. It's tiny, but it's there. So the thing we need to notice about this triangle is that there is a 90 degrees right here. 90 degrees, and then we're trying to find this side. So if you remember, the opposite of 90 degrees is called the hypotenuse, so we can use the Pythagorean theorem to figure out what this side is. All we have to do is figure out what this side measures, which in a way we're given, and what this measures, which in a way we are given. We just have to do a little bit of figuring. Alright, so how we figure this out is from here to here is 6 centimeters. So half of 6 centimeters is 3 centimeters. So again, we're dividing this line in half. You can see that. From here to here, that is 3 centimeters. So all we really have to do is figure this out, and then we can use a Pythagorean theorem. Now we know from here to here, all the way to the top here, from here all the way to the top is 30 centimeters. We know from here to here is 26 because that's shown up here from here to here. So all we have to do is subtract those two, which minus 26, to get this side, which is 4 centimeters. So we have 4 and 3 centimeters. So now we can actually use the Pythagorean theorem to figure out what that side is. The Pythagorean theorem is a squared plus b squared is equal to c squared. You could also have had c squared is equal to a squared plus b squared. Both are accurate. Alright, so now we just got to plunk in our numbers. So the a is 3 squared, plus b, so we said this side measured is 4, so 4 squared is equal to c squared. 3 times 3, not 3 times 2, 3 times 3 is 9, plus 4 times 4, which is 16, is equal to c squared. When we add these two up, we get 25 is equal to c squared. Now we can't leave it like this. Of course, we have to find the square root. That's going to give us c, and the square root of 25 is 5. Alright, so now we have all of our dimensions because we know now this is 5 centimeters. This is 5 centimeters. So we have all the dimensions in, and we can start drawing our picture. So we start by, and I like to unfold it and think about it. You can think about it however you want, but I'm going to start my diagram with this little box here. So it's like we're cutting it down the seam and then just unfolding it. So I know I'm going to start with a very thin line. Okay, that is this part here. Then we know there's a fat part. Then of course the other side to this is a thin part, and then a fat part. So again, we need to do the same on this side. So we have make sure that's pretty even, thin, fat, fat, thin, and fat. Now we just connect all these lines. And your picture might not be absolutely perfect because it's kind of hard to draw a perfect diagram with no dimensions already on here, no lines already on here. So you're just going to do the best you can with your ruler. And you're going to draw this line in. And you're going to draw this line in. And then the last line in. So really all we've done right now is we've done this part of the diagram. We've really just done the box. We haven't looked at the top part yet. So we need to make sure that we draw that in right after we draw in this side, and that side is a big box. That's going to be this side right here. That's what we're drawing right now. So we'll include that there, that there. We're not going to write the dimensions into the very, very end. Right now we're doing the unfolding of the box. And then we're going to draw these little triangles in. It's hard to draw with a ruler, so you're just going to draw that part freehand. But on mine it looks like this one is bigger than this one, but they are both supposed to be the same size. Alright, so we have to draw, so that's this side and the other side of that. Now we have to draw this flap and then the flap on the other side. So you do that by just connecting this. And then connecting this. And then you're going to connect that, and then you're going to do the other side. So that's the top side and then the other side. And then we'll draw this one in. And then we're going to just draw the end. Okay, now that we've actually drawn or unfolded our object, now we have to add all the dimensions in. So we know this line here measures the same as this line here, which is 26. So we'll include that all the way down, 26 centimeters, 26 centimeters, all the way down. All right, so now we're going to include this one. That's 6 centimeters, which is right there. So we'll go 6 centimeters. And we know the other one over here is 6 centimeters. Now, how much does this measure? We know that measures the same as this, which we said was 10 centimeters. So let's include that. 10 centimeters, 10 centimeters, and of course this is 10 centimeters. All right, so how much does this measure? Well, it should measure the same as this, which is 10 centimeters. And this should also measure the same, so let's write that in there, 10 centimeters. Now all we have to do is label these sides and these two. Well, we know with the Pythagorean theorem that this measures 5 centimeters. So this one must measure 5 centimeters. This measures 5 centimeters, this measures 5 centimeters, so this measures 5 centimeters, and this measures 5 centimeters. And that's it. So it's unfolding again, it's unfolding a 3D object, and then you need to make sure that you put all of the dimensions in. You could have gone on this side too, but that would be almost redundant. So long as you have one on one side, that we would accept that.